reciprocating engine, and this one is your piston, this one is connecting rod, this one is crank, this one is center of crank. Let's assume that the crank is rotating in this direction at a speed equal to omega. Let theta is the angle made by the crank. Let r is the radius of the crank. Let L is the length of connecting rod. This one is connecting rod. L is the length of connecting. Let's say gamma is the angle made by the crank with the line of stroke. This one is gamma, is the angle made by. Let me define one term that is called as N, and is the ratio of L divided by R. Length of connecting rod divided by crank radius. Naturally, the length of crank is always greater than crank radius. So is this value is always greater than unity, and is it a very large value as compared to 1? So in today's lecture we want to find out what are the forces involved on the reciprocating mass. This one is called as reciprocating. To find out the forces, what we required is force is given by what? Mass into acceleration. And we can write this term as m into what? X double dot. To find out acceleration, we must know first velocity. And to find out velocity, first of all, we must know the displacement. So first of all, I will develop the equation for displacement. Then we go for velocity. Then we'll go for acceleration. And then see what will happen to this slider crank mechanism. Imagine that this crank is at this position now. That is at this position. When the crank is at this position, is the connecting rod will extend from this side, will go to this side. And at the given instant, this is called as dead center. Right now, is this piston is some distance away from the dead center. Let call distance equals to, let call this distance equals to x distance. So at any time, from top dead center, what is the current position of the piston, we can find out. So x is the distance from TDC of the piston. So the distance between TDC to this crank center is this distance. If extended, this r will come here and L will go this side. So is this total distance is L plus r and L plus r. I want to find out this distance from here to here. For this purpose, what I do is that I will draw perpendicular from this point. And if I draw this perpendicular, I will extend this perpendicular to this side. And I will say that is this distance plus this distance, is it same as L plus R plus X. So this distance is it L, this one is gamma, this one is 90. So is this distance is L cos of gamma. L cos gamma. And this one is theta, this one is R. So is this small distance is r cos theta. So can we say that the distance x is equals to the total distance is L plus r minus this distance is L cos gamma. This distance is what? R cos theta. In this equation, the value of x is dependent on gamma and value of x is also dependent on theta. So right now x is a function of gamma and theta. To make this differentiation simple, we will try to make the derivative of x with respect to one function only. So we will try to have some relation between theta and gamma. So we want to make some relation between theta and gamma. I want to establish relation between gamma and theta. For this I will apply sine law. According to sine law, the side of a triangle, that is r, is always proportional to sine of the angle opposite to it. So r divided by sine gamma is always equals to L divided by sine of theta. So I have definite relation between sine gamma and sine theta. So what is value of sine gamma? Value of sine gamma equals to, is it r divided by L, is it multiplied by sine theta. So I am successfully developed the relation for sine gamma, but I am need in what cos gamma. So what is cos gamma? Can we write cos gamma is equals to under root of 1 minus sine square gamma. This, what is my n? Is it L by r? And this one is what? R by L. So is this term is sine theta. divided by n. Cos gamma I written as basically cos gamma, cos square theta plus sin square theta equal to 1. So cos gamma equal to under root of 1 minus sin square gamma is equals to under root of 1 minus sin square theta divided by n. What is that value? So if I take out n square common, it will become under root of n square minus sin square theta, and finally I will take down n common. Is it 1 by n into bracket, is it n square minus sin square theta for what? Cos gamma. Now here, can we replace this L as a product of n multiplied by r? This L will replace as product of n multiplied by r plus r. I open the bracket. This one is minus L. Minus L is same as n into r. So this is n into r. Can we replace cos gamma by this term? So is 1 upon minus, this is minus and plus. Is it another minus? This one is r, and we'll write this equals to cos theta. Now what is the difference between previous equation and this equation? Is this term of x is entirely function now of theta only? Is it a single valued function? And previously it was a function of what? Gamma and theta. So this is very easily differentiable now. So at any instant, if you want to find out displacement x, and if you know the crank radius and the connecting rod length, and you want to know what is the crank, then you just substitute this value, you will get your position. And the derivative of this one with respect to derivative of this with respect to time, is it a velocity? But remember one thing, here x is a function of theta. So if you want a velocity, you have to differentiate x with respect to what? Theta. In that case, it was calculated as dx by d theta multiplied by d theta by dt. Is it correct? What is d theta by dt? Rate of change of angular velocity. Is it omega? Omega. So this equals to what? V. This equals to what? Omega multiplied by what? Dx by d theta. Agree? This term is dx by dt. Dx by dt is same as dx by theta is same as d theta by dt. But what is d theta by dt? Is omega. So omega is extra term we are getting. Okay, now tell me what is the derivative of sin theta? Derivative of sin theta is what? Cos theta. And what is the derivative of cos theta? Minus sin theta. If it is a sin square term, is it correct? Then is it 2 times sin theta? First is same, 2 times sin theta, then multiplied by what? Cos theta. Okay, so we have a composite function here, so you have to handle very carefully. First is velocity is dx by dt. That is the derivative you have to obtain with respect to what? Time. With respect to time, neither the crank radius will change, neither the length will change. They are always fixed. So is the derivative of the first term is 0. If the derivative of the first term, this one is 0, and this n cancel out. We left with minus r. Now this one is under root sign. So x to the power 1 by 2. Derivative is 1 by 2, x to the power minus 1 by 2. And the composite function will handle separately. So this is multiplied by 1 by 2. This one is n square minus sin square theta. Is it to the power minus 1 by 2? To differentiate this, so I will open bracket. What is the derivative of n square? 0. Now what is the derivative of minus sin square theta? So first is minus 2. Is it sin theta multiplied by what? Cos theta. And one term is of what? Omega. That is this entire term. Is it multiplied by d theta by dt? Correct? Is it first is okay? Now start with second term. Is it minus r? What is the derivative of cos theta? Minus. Is it again multiplied by d theta by dt? That complete derivation. Now we have two terms. One term is this one and one term is this one. Is both the term contains r. So we'll take out r common. So this one is v. R is common. Now we'll open the bracket. This minus sign, this minus 2 sine theta, and this minus sign, is it positive sign? 2 sine theta into cos theta, is it divided by, I think this 2 and this 2 also cancel. This 2 and this 2 cancel. So let's eliminate this. And this power is what? Minus 1 by 2. Can we write this term as n square minus sine square theta to the power 1 by 2 now? Okay, this all thing finish and multiplied by what? Omega. This omega and this omega, I will keep it outside. So I will write here, this one is omega. I have to write this term. Is it minus minus is plus? So this one is plus. R is already out. And is this term is sine theta. Okay. This term I am able to write down sine 2 theta. If I multiply by 2 extra and then immediately divide by what? 2. Now as far as denominator is considered, this one is n square. And what is n? Is it L by R? And is this ratio is very large as compared to 1? What is the value of sine theta? Is the maximum value of sine theta is 1. Maximum value of sine theta is 1. So is this ratio, that is n square and sine square theta, is it almost as good as n square? Because we are assuming here n equal to what? L by R. Length of connecting rod is very large as compared to crank radius. So what we do is that n square is this term is very large as compared to what? Sine square theta. In that case, is this term is only n square. If you write shift on this side, is it equal to 0? Is it correct? So this small modification will make. So we'll assume this term approximately equals to what? N square to the power 1 by 2. So is it only n? Velocity equals to r omega. Omega I will prefer first, and then I prefer to write sine theta. So this term I will write first, and this term is what? Is it sine 2 theta? So this one is sine of 2 theta divided by this 2 extra, and this term is what? N square to the power 1 by 2 is same as n. R into omega, what is the derivative of sine theta? Is cos theta. And this theta, and again will come 1 d theta by dt. So this one is d theta by dt plus, what is the derivative of sine 2 theta? 2 into cos of 2 theta, and is it divided by 2n, and is it further multiplied by d theta by dt? Is this fine? Now this d theta by dt and this theta by dt, is it again omega? So this omega and this omega, so his acceleration is given by r into omega square. First term is what? Cos theta. And what is the second term is? This 2 and 2 cancel. Is it cos of 2 theta divided by n? So this is our final equation of acceleration. And is it consist of 2 parts? First part is cos theta and second part is what? Cos of 2 theta. By Newton's second law, force is defined equals to what? Mass into acceleration. So is this acceleration consist of m r omega square cos theta plus m into r into omega square, is it multiplied by cos of 2 theta divided by n. So total force, is it consist of two parts, first part and second part. So these are the forces involved. Is this quantity same as yesterday's centrifugal force? So part of centrifugal force is responsible for acceleration of what? Piston. And this one is m, is the mass of piston. This one m is the mass of piston, or we can say mass of reciprocating mass, mr. So total force is consist of two parts, first part and second part. This one is called as primary force. This one is called as secondary force. One is called as primary force and one is called as secondary force. So you have to balance both forces. That is the primary force you have to balance, and you have to balance the secondary force also. That is called as complete balancing of reciprocating mass. First of all, we'll try to balance primary, and then later on we'll try to balance the primary plus secondary. But first of all, my focus will be only on primary.